Okay, folks, so we have been working on multiplying polynomials binomial by a binomial, but it actually is possible to multiply larger polynomials, and we're not going to go crazy with this. Here I have a binomial multiplied by a trinomial, and I want to just show you how you can just still use the distributive property to do this. You could multiply any size polynomial, but we're not going to start multiplying polynomials that are 4, 5, 6 terms long. That doesn't come up that often in applications, and it's really just nothing but torture. So I want to show you here how we can multiply polynomials that are larger than binomials, but not real ridiculous. So let's take a look at this here. All right. So what we have is we're going to follow the distributive property. So we're going to start with the 3x. And we are going to distribute that 3x to every term over here. Except now, since this is a trinomial, I have 3 terms to multiply by. So the only difference between this and the problems we've been doing for the past week or so is that now when you distribute this term over here, you are multiplying by all 3 terms. Okay? So 3x times 4x squared, that would be 12x cubed. And then 3x times 5x is 15x to the second. And then 3x times minus 3 is minus 9x. Okay? So when we were multiplying with binomials, we would distribute and we would get 2 terms from that first multiplication. Now we get 3 terms. Okay? But now, much like before, we're done with the 3x. And now we move to the 5x. So now I'm going to take the 5x and I'm going to distribute it to all 3 terms. Okay? So 5x times 4x squared, that's 20x to the second. Right? I'm actually going to write it underneath since I'm running out of room going this way. So 5 times 4x squared, that's 20x to the second. I'm going to write it under here because I know I'm going to combine it with the 15x to the second. 5 times 5x is 25x. And then 5 times minus 3 is minus 15. So now we're going to just combine the like terms. Okay? So if we go ahead and we do that, 12x cubed, there's nothing to combine that with, so it's just going to be 12x cubed. 15x squared plus 20x squared makes 35x squared. Right? Negative 9x plus 25x. So a negative 9x plus 25x makes 16x. And then the minus 15 doesn't have anything to combine with. So that's your final answer right there. You have 4 terms in your final answer because you can combine a couple pairs of the terms. 12x cubed plus 35x squared plus 16x minus 15. All right? So it's very similar to the problems that we have been doing with the binomials, except the distributive properties just extended a little bit because there's a few more terms in the second polynomial. All right? So let's try a couple more of these just so you can see. Okay? So let's say I'm going to do 5x minus 4 times the trinomial 4x squared minus 4x and plus 3. Okay? So just like we did last time. So now I'm going to start with that 5x. It's a 5x here. All right, so I'm going to start with that, and I'm going to distribute the 5x here to all 3 terms over there. All right? So 5x times 4x squared, that's 20x to the third. 5x times minus 4x, that's minus 20x to the second, because x times x is x to the second. And then 5x times 3 is 15x. Okay? So I multiplied that 5x by each of those terms. All right, now I'm going to go to the minus 4. Okay, and I'm going to distribute that to each of those terms. And again, I'm going to write it underneath since the board, I don't really have room to go all the way through. So negative 4 minus 4 times 4x squared, that'd be minus 16 x squared, right? Minus 4 times minus 4x is going to make plus 16x. And then minus 4 times plus 3 is going to make minus 12. And then we're just going to combine the like terms, right? So we distributed the 5x, we distributed the minus 4, and now after we combine the like terms, you have 20x to the third here, which doesn't have anything to combine with, but minus 20x squared minus 16x squared is going to make minus 36x squared, right? Put them together. 15x plus 16x will make 31x. And then the minus 12 has nothing to combine it with. Okay? So, you simply distribute each term here times all the terms there, and then you combine the like terms afterwards. Okay? Let me give you one more for you to do on your own here, and for you to try. Yeah, even a few less numbers on this one. So let's have you, make sure the board stays going forward. Let's have you try x plus 3 times 2x squared minus 6x plus 5. Okay? So why don't you go ahead and you try to multiply that out, pause the video, okay? And then we'll come back and we'll see how you did. All right, so here you should have multiplied the x times each of these terms over here, right? So x times 2x squared, that's 2x cubed. X times minus 6x, that's minus 6x squared. And x times 5 is 5x, right? After you distribute. Okay, now we move to the 3, okay? So we move to the 3, and we're going to distribute the 3. 3 gets multiplied here. So 3 times 2x squared, that's 6x squared. Ooh. Right? 3 times minus 6x will be minus 18x. And then 3 times 5 is 15. And then we combine the like terms. Now here we combine the like terms, and look what actually happens. The 2x cubed is here, and actually the x squareds end up canceling out. Minus 6x squared plus 6x squared adds up to 0. So you don't have an x squared term in your answer. 5x minus 18x, that'll be minus 13x, and then you have the plus 15. So in this case here, it turned out that the x squareds completely canceled out. And so your final answer is a trinomial, only has 3 terms. Okay? So it's still the distributive property. It's still what we've been doing. It's just a little bit longer. I'm going to show you one more that is a larger polynomial. Like I mentioned, we're not going to do ones that are outrageous as far as their length. But I do want to show you that it's possible if you wanted to do larger polynomials. So let's say, for example, I had 4x squared minus x minus 4, okay? And then 3x squared plus 4x and minus 3. These are 2 trinomials that I want to multiply together. Now, we're not going to do too many like this at all, because they take, it's just tedious and long. But I do want to show you that it's possible to do multiplication of any length polynomial. Okay, so let's just do what we've been doing. Let's start with the 4x squared, and let's distribute that here to that second polynomial. So 4x squared times 3x squared, that'll be 12x to the 4th, right? Because x squared times x squared is x to the 4th. 4x squared times 4x, that'll be 16x to the 3rd. And then 4x squared times minus 3, that'll be minus 12x to the 2nd. So that's distributing the 4x to the 2nd. Now we're going to move along and we're going to distribute the minus x. Minus 1x, remember, gets distributed. So minus 1x times 3x squared, that'll be minus 3x cubed. I'm going to put it right underneath here, minus 3x cubed. Right? And then minus 1x times 4x, that'll be minus 4x squared. And then minus 1x times minus 3, that's positive 3x. Right? Remember, when it's a minus, you're distributing, all the signs are going to be opposite. Okay? And now we're not done because we have a trinomial and a trinomial. So now I need to take the minus 4 here and distribute it as well. So minus 4 times 3x squared, that'll be minus 12x squared. So again, I'm just going to stack them underneath the like terms there. Okay? Now, minus 4 times 4x, that'll be minus 16x. And then minus 4 times minus 3 will be plus 12. That I'll sneak here in at the end. Okay? And now I'm going to combine all of those like terms. And when I combine the like terms, the 12x to the 4th doesn't have anything to combine with. The x cubed, 16x cubed minus 3x cubed, that's 13x to the 3rd power. Minus 12, minus 4, and minus 12. Add those all up, combine them, and it makes minus 28x to the 2nd. 3x minus 16x, that's minus 13x. And then the constant 12 doesn't have anything to combine with. So that would be our final answer right there. So for that problem, I just wanted to show you, hey, you know what? We can multiply polynomials at any size. We're not really going to do too many that are that big or larger. We're going to stay focused mostly on the first few that I showed you here, which is a binomial times a trinomial. Because if you can do that and get the hang of that, then really you'll be able to apply that to any size polynomial that you need. Okay? So rewatch this video as many times as you need. Work on the practice over the next couple days. We're going to be working on this for a couple days, for 2, 3, 4 days. So don't worry about mastering it today. Work on the practice and email me if you have questions. All right, great. Have a good day.